The purpose of this video is to give you an example of the crossing graphs method using your graphing calculator that you can refer to for assistance anytime you would like. I'm going to look at example number 2 from our section 2.4 notes. We have a function given for a skydiver's downward velocity x seconds after he has jumped. The question asked is when will his downward velocity be 150 feet per second? So the question of interest, the equation we need to solve, is 176 times the quantity 1 minus 0.834 to the x power equals 150. Again, we will do this with the crossing graph method in our graphing calculator. So we go in first into the y equals menu, and we want to enter both sides of the equation. The left-hand side of the equation, 176 times the quantity 1 minus 0.834 raised to the x power. I will put in as y1, and then the right-hand side of the equation, 150, I will put in as y2. Second, we need to find a window, a viewing window, where we're able to see the point of intersection. We do this first by setting up a table. Start your table at 0 and then choose a number to count by. In class we have been counting by either 2s or 5s, and that should be sufficient for this problem as well. So I will count by 2s, and then I need to make sure that both the independent and dependent variable are set to auto. We will now go into the table by doing second graph, and what we will look for is when does our function, which was in y1, when does it pass 150? So we notice at x equals 10, we're at a level of 147, which is still less than 150. But at 12, we're now at 156. This tells us that somewhere between 10 and 12 is where our function equaled 150. So I'll go back into the window, set the x minimum for 10, the x maximum for 12, and then by doing zoom 0, the calculator will automatically find the y values for our viewing window that lets us see this point of intersection, where my function representing the skydiver's velocity crosses the line at a height of 150. Now to find the location of this intersection point, we will go into the calc menu, so I need to press second, trace. Option number 5 is the point of intersection, and then I follow the on-screen directions. We will be asked for the first curve. As long as this says y1 up here, we're fine and we can press enter. If it does not, you can use the up and down arrows to move the cursor from one function to another that happens to be stored in the calculator. So first curve, y1, we press enter. The calculator now asks us for a second curve. Again, we will now want this to say y2. If it does not, we can use the up and down arrows to get to the right function. Once we have y2 up there, we can press enter again, and then we are asked for a guess. The guess can be skipped and by just pressing enter, and then you will not have to do anything. If there is more than one point of intersection on the screen, you will need to move the cursor close to the point of intersection by using the left and right arrows and then pressing enter. Again, if there's only one intersection point on the screen, you do not have to do this step. You can just press enter. If there are 2 points of intersection on the screen, you have to let the calculator know which one you want it to find. Once the cursor is in place, you press enter, and then the answer appears at the bottom. So our function will hit a height of 150 after a little more than 10.5 seconds.